Welcome everyone. My name is Peter Zsíros, and now we are going to talk about the Windows password storage, how the Windows store the passwords and how we can attack them. We will need 3 virtual machines. At the beginning, one is enough, and later we will use 2 other ones because we will do man-in-the-middle attacks as well. So at the beginning, we have 1 virtual machine. This one, it's a very nice Windows 2016. There is nothing interesting installed in it. This is the default settings. And one of the way how the Windows store the password is the so-called service passwords. So if you go to the Windows administrative tools and here find the services, here you can find a lot of nice services. Now I will find a not important one. For example, I will use the print spooler service because I don't want to print anything. Here is the print spooler, and thus I hope you know that you can set here the logon, and here you can change the account what it is going to use. Now I choose an account. For example, I will use the administrator account because I don't have anything else. Administrator. Okay. And I will type the password of it. This is password 1, but you can type any password. It don't have to be the correct one, because the only important thing is that when you click on the OK, password 1 and password 1. When you click on the OK, first of all, it grants the logon as service right for the given user, so for the administrator now. Okay. And it warns you that the new logon name will not take effect until you do not stop and restart the computer, or at least the service. Now I don't restart the service because the important thing is already happened. The computer has already saved the password for us. It is saved to the HK local machine security tier. As you can see, I'm not able to see it. Even if you are an administrator, you are not able to see it because by default, you don't have right for it. If you go to the permission, as you can see, for the administrator does not have right. Of course, I can give myself right and check it, but I won't do it because I don't want to change the default settings of the computer. So I don't want you to believe that it works only because of the changes. So this is one thing, the print spooler services, or more exactly any service account password, and it is stored in the registry as I have shown it. And I hope you know that the registry is stored physically in the C Windows System32 config directory. And here is the registry. And here you will need the security file and the system file. Those 2 are required if you want to get these kind of passwords. But if I am here, I want to mention the 3rd file, the SAM file. When we will talk about the Windows login passwords, which is a very common target in case of Windows operating system, then you will need the SAM and the system files. As you can see, the system is common. You always need that. And you will need the SAM of the security depending on the password type. Practically, this is the rule. But if you have these 3 files, then you have everything. I guess you know that. If I try to copy, for example, these files and copy it anywhere, for example, here I create a new directory. I will call it as A and try to paste it here. I just get a warning message. The action cannot be completed because the file is open. You are not able to copy just on this way these kind of files because this is the registry and the Windows continuously use the registry. It is always open, so practically you are not able to copy it on this way. Of course, there are some low-level techniques how you can copy it, but for that you have to write your own application or take a Google search and you will find those kind of application. But I want to show you now another technique how you can grab any open file. It works on Windows Server machines because on the client machines there is one command missing. we will use the VSS admin command. And as you can see, it gives us a very nice menu. And on client computers, it is a much shorter. You will get only the list shadows and list volumes, but there is no create shadow possibility on client machines. It depends on the Windows client if there is shadow copy possibility or not. Sometimes it is yes, sometimes it is no. So for client, it is a bit more difficult question. You can try to create a shadow copy. On the way you go to the C, properties, here is the shadow copies, and you can create here. And also, this is exactly the same what we are going to do now on the command line. So if you prefer this way, create now, just use this one, but I will show the command line version. So we are here, and we want to create a shadow copy. What is the shadow copy? The shadow copy is the snapshot of your current volume. You are able to create a shadow copy only from a volume, not from a file, not from a directory, but from a volume. That's the smallest entity what you are able to create a shadow copy from. And to create a shadow copy, we must use this VSS admin create shadow command from command line. If I use this command, as you can see, it just gave me the help because it was not correct. I have to give the partition name, for example, C column, what you want to create the shadow copy from. So I want to create the shadow copy from the C drive. So I will use the VSS admin create shadow /4 equal C column. This is my command, and it runs, and it was printing me some little text. Shadow copy volume name, I got this text. So as you can see, it is something similar to a share folder, so something like a link or a share. So maybe your first idea is to go and connect to this share. I try to connect, but I just get an error message, it is not working. Why it is not working? If you take a look at the beginning of this link, there is this / / ? /. This is a very interesting thing, this / / . Why it is interesting, I'll show you. I guess most of you know that if you are working on Linux operating systems, everything is file. So if you create a process, that's a file. That's represented as a file. So everything is represented as a file. There is some similarity in case of Windows, not exactly that, but there is some similarity. For example, you can make the following experiment. You type the echo command to print out some text, for example, some letter A, and redirect it, to a file, and let us call this file as com1. Or exactly C colon / com1, because I'm in the C directory now. And it gave me a very interesting error message. The system cannot find the file specified. Yes, of course, who cares? Create this file. This is what I want. If I type here another name, for example, abc.txt, no problem, it creates it. But if I type com1, it gave me an error message. Why does it happen? It happens because the com1 is a special name. As you know, this is a Windows device, the serial port. Similar thing happens if you try to use the LPT1, does the parallel port, and so on, com2 or similar. So, as we can see, it is not working in this way, but how it is working, you can do the following trick, / / ? You write it to the beginning, and use the same command again, enter, and it works now. If I come here, really, I got this com1 file with 9-byte length containing some letter A. If you try to open this file with anything, then it will not be possible. So if I come back and the C root, and where is my com1? Here it is, com1. I double click it, try to open with Notepad, for example, com1.txt. No, I don't want the txt file, I want to open this one. So no, thank you. Or if you try to delete it, cannot delete it, try again. No, it can't. So it's impossible to do anything with this file, because now the operating system always try to do something like that, C column backslash com1, and it is not working. You have to use again the backslash question mark backslash at the beginning, and now it is working. So this backslash question mark backslash practically orders the operating system to not take care of not try to resolve the name, but use it. So it just do it and not try to resolve or figure out what happens in the background. This is what you order the computer for. So this backslash question mark backslash at the beginning of this share or of this address means something similar. This is some internal namespace what we are trying to use, and simply you are not able to open it on normal ways. Then how can you open it? You can open it on the following way. We are able to create symbolic link to this target. In case of Linux, most probably you know that it is very common to create symbolic links. On Windows, it is not so common, but you can create symbolic links with the mklink command. If you run the help of it, mklink, then you can see it has a /d to create a directory symbolic link, or create hard link, or junction point, and so on. Sorry, these are the free ones. And also you have to give a link name and the target. I have the target, that's the long text here. This is my target, so I have the target. And for link name, you can use anything, but you have to take care with the following. This shadow copy represents your whole C drive. So it is not good if you create a file symbolic links or normal one, but you have to create a directory symbolic link or junction, directory junction. The important point is to create a directory, because this is a whole drive, not only one file. It's very simple. So mklink /d, it will be a directory, and I will call my symbolic link as, for example, ABC, whatever you want. It will be the name of my directory. And this directory will point to this destination. And you have to take care one more thing. You have to add a backslash to the end. Be very careful with this backslash at the end, because if you forgot to add it, it seems to be working, so it creates the link, but it will not work. So please be careful to add the backslash to the end. Okay, now the link is created. I have a ABC, and it points to the destination. And now if I come back, I have here this ABC directory, or exactly a link. As you can see from the icon, it has a little blue arrow at the bottom. It is similar to the documents and settings, because I hope all of you know that since Windows Vista and Windows 2008, there is no document and settings directory. There is the users directory, where everything is contained, which was in the document and settings. The document and settings is only kept here for compatibility reasons, and it is only a link for the users directory. So I go to this ABC, similar to the documents and settings, so it is just a link. And if I come here, you can see again my C drive, but this is not my actual C drive, but this is my C drive at that time when the shadow copy was created. And because this is the old version of my C drive, of course, there is no open file on this C drive, so I'm able to copy, use, or do whatever with every file. Of course, you are not able to delete them, because this is a read-only snapshot. But I can, for example, go to the Windows System32 config directory, and here find the SAM, the security, and the system files, Ctrl-C, and I come back here and paste it to my C drive and A directory. And as you can see, I was able to copy it now, so those files were not open. because those are the shadow copy versions. So this is how you can copy OpenFile with built-in Windows features practically. Oh, of course, you have to be administrator to do such a thing. Normal user is not able to create shadow copies, but shadow copies are very often created automatically by the system. For example, in case of Windows 7, it is created when you install a new driver and things like that. So practically the Windows try to defend itself for destroying or something for destroying. That's why it creates a shadow copy if there is some dangerous things happened for the operating system. So maybe you can find on the operating system already shadow copy, so you don't have to create it, just use it. To use it, you have to use the vssadmin list shadows command, and here are the shadow copies created on the system. Now I have only one, this one, but there can be many on the system. Okay, so if you don't have right, then try to look around if maybe there is one. There is already one. Okay. Now I have the 3 files, and I have to get the username and password from these files. Of course, you can do it manually, but it's very difficult and time-consuming, because there are 2 files because of the following reasons. The Windows stores the passwords on the following way. There is the, it will hash your passwords, but it will also encrypt that hash, encrypt, with a symmetric encryption, the password hash. And for the symmetric encryption, you will need a key. And this value is stored in the security file. And we have an encryption key here. The encryption key, it is stored in the system file. So this is why you need the system file, because you read from there the encryption key. Then you will be able to decrypt the password hash of the password. It depends on the situation. And then you will get the password hash what you are able to break. In case of the service accounts, the situation is a bit simpler, because if you think about it, when you start a service, for example, a spin spooler, when you stop and start it, then the Windows practically have to type your password. It must give your password to the operating system. Even if it is the Windows itself, it must use that password. So it's quite clear that in this case, the password must be stored in some kind of symmetric encryption. So it must be able to reversible. So the hash is not good. In this case, the password itself is stored. So for us now, the situation is very easy. We just have to read the encryption key from the system file and decrypt the data in the security file with that encryption key, and then we will get the password itself. But even to do it, it's a bit difficult to do manually. That's why most of the time we are using tools for it. Now I'm going to use the Kane enabler. That's a fine tool for this purpose. You can download it from the www.oxid.it. And there is the Kane enabler, and I install it. Next. Installs, finish. Do you want to install WinPCAP? It won't be able to install it. As you can see, I got an error message. You can install the WinPCAP separately, or you can install the Wireshark or the, how is it called? Nmap. Those brings the WinPCAP also, and it has a newer version built in, and that installs to the Windows 2016 as well. Okay, it is installed. And now I run the application. Hopefully it will be run. Oh no, yes, I have to install the WinPickup as well. No problem. The WinPickup can be downloaded from the www.winpickup.org. And there is the 4.1.3 version. And I just install it. It is installed. Now it is fine. I start the application. It's a bit slow. Okay. Now it is started. And here is the LSA secrets. That's what we need. Plus sign. And you can try to get it from the local system, but it is not used to working. Your computer, I will show it later. It only freezes your computer. And I go to the C drive and open the files I just copied. I will need the system and the security files. First the system, then the security. Next. And here is my SC spooler, the pin spooler, and here is the password, what I typed, password 1 with capital P. It was my password. As you can see, it is stored in Unicode. Those are clearly Unicode characters. This is a feature in case of Windows, it is stored as a Unicode. Okay, so those are the system, these are the system, the service passwords. Okay, now let's see some other stuff, how to get the Windows login passwords. So most of the time when we are talking about passwords and how to get them in case of Windows, then most people think about this logon passwords, the Ctrl+Delete password. So this one. Okay, let's see how one can get it. Similarly to the previous case, we will need the registry because it is stored in the registry. And there are two files what we will need. One of them is the SAM and the other is the system. And again, the situation is very similar like earlier. Now, the password is stored on the following way. We encrypt with a symmetrical encryption the password, but now not the password itself, but the hash of the password. And for the symmetric encryption, you will need a key. And it will be stored in the SAM file. So this is in the SAM. And the encryption key, it is stored again in the system file. So again, we do the following thing. From the system file, we get the encryption key. And by the help of that encryption key, we are able to decrypt the symmetric encryption, and we will get the hash of the password at this time. So this is the more difficult situation when not the password encrypted, but the password hash is encrypted once more. Okay, the question, now you will get only the password hash, not the password. So the question, what can one do with the password hashes? There are many possibilities. One of the possibilities is to try to crack the password hash. And let's see how it can be done. The Windows can store the password in two different formats. One of them is the so-called LMHash, while the other one is the so-called NTLM. Those are the two formats. Honestly, today only the NTLM is used. Since Windows 2008, the LMHash is disabled by default. Oh, and on client operating systems since Windows Vista, the LMHash is disabled by default. So hopefully you will not meet with LMHash. But of course, as I guess you know, even today you are able to meet with Windows 2003s in some environments. So even maybe it can happen that you see some kind of old machines which are still storing the password in LMHash. If you see some LMHash, then you are very happy, because it is very simple to crack the LMHash. And why it is very simple to crack? It is very simple to crack because it works on the following way, how the LMHash is working. I will try to draw some kind of picture about it. Okay. Great. So the LMHash works on the following way. You have a password. So here is your password. Oops. Password with some lengths. And the Windows will extend it to 14 characters exactly. It will add as many null character to the end as necessary to be exactly 14 character. Why 14 character? Because you can divide the 14 with 7. So it is divided to two 7-byte parts, one times 7 byte and the other times 7 byte. So it divided to two parts, 7 and 7. And why 7 bytes? Because if you know that, there is an encryption algorithm called DASH, the encryption standard, DASH. And the DASH uses 56-bit case, and 56-bit, that's exactly 7 byte. More exactly, the DASH uses 64-bit key length, but 8-bit are parity bits. So only 56-bit is a k-bit and 8-bit are parity bit. So that's why you have to give it 7 byte altogether. And the DASH is a symmetric encryption algorithm, so it must encrypt something. It will encrypt a magic value, that's the KGS, exclamation mark, percentage, hash mark. Sorry, I mistyped it. It's KGS, exclamation mark, @ hash mark, $sign, and percentage sign. Yes, this is. It's a bit difficult on this way, but it's simple to remember. Just a moment. Because this is nothing else but on English keyboard, the KGS and shift 1, 2, 3, 4, 5. So this is the command. And this magic value will be entered to the DAS. The DAS will encrypt this magic 8 bytes. And of course, 8 byte will fall out from the DAS, because during the encryption, there is no data loss and no increase of data. So I will get exactly the same number of bytes. If you encrypt 8 bytes, then you will get 8 bytes. And the same characters will fed into the other DAS algorithm. And you will get here 8 byte, and you will get here another 8 byte. And you copy those 2 times 8 byte, one after the other, and it will be altogether 16 bytes. And this is the so-called LMHash. So this is how it is stored. So why is it so weak? It is so weak because of the following thing. Let us calculate the password space practically. As you can see, there are 14 characters maximum. So if you think about 14 characters, an average user uses small letters, capital letters, and numbers on the password. The English alphabet contains 26 characters. So small letters plus capital letters plus the 10 number. That's altogether 56 if you add it. So if you have a 14-character password, then the password space is 62 to the power of 14. So this is all the possible passwords, what is a quite huge number. But the LMHash converts the password to uppercases. So this password here contains only uppercases. So instead of 64, there is only 36 to the power of 14, which is still a quite huge number. But if you take a look at this calculation, the password is divided to two 7-byte parts, and we calculate with those two parts totally independently. So it will not be 36 to the power of 14, but it will be 2 times 36 to the power of 7 only. And the other thing, the same magic value is fed into the Bose-dash algorithm. So this is the same magic value. So if you run through on the dash address space, then you will get one part and you will get the other part. So practically this 2 time is not necessary because of that. So only remains 36 to the power of 7 as the password space. So while originally it was 62 to the power of 14 combination, because of the algorithm, only 36 to the power of 7 remains, what is a much smaller number. And with the today computers, it can be broken within hours. So it's a very weak password storing mechanism. So this is how the LMHash works, and it's very simple to crash, but most probably you won't meet with this algorithm because, as I mentioned, since 2008, it is not stored by default on the machines. Okay, the other storing method is the NT-hash. The NT-hash works on the following way. This is nothing else but the MD4 hash, not MD5, MD4 hash of the Unicode password. So that's why, if you recall, the password stored on the registry on the previous example was Unicode, and this is why it is stored in Unicode. And the MD4 hash of the Unicode password is the NT-hash. As you may know that the MD4 is not a safe, even the MD5 is not a safe algorithm anymore because there are collision attacks against them. So practically it is not a safe storage method, but there is nothing better on Windows, so you cannot do anything else. To tell honestly, this collation, we don't know any attack that uses the collation against passwords. Maybe there exists, but we don't know about it, so it is not public if it exists. Why we don't know about it? Because those collation attacks generate some kind of input that gives you the same MD4 hash. So practically generate you a password, not the same password, but some password that gives you the same hash. But during this generation, the Unicode specialties are not taken consideration, and the keyboard things are not taken into consideration. They are created for files, not for passwords. So for example, when you are entering a password, your case set is very limited. Practically, for example, you are not able to enter a tab character because that has some meaning. If you get some value which is equal with the shift, you are not able to enter it, or with the control key, that's you are not able to enter it, or it is equal with the enter key, you are not able to enter it. So it can work only with a collision algorithm, which takes into account the specialty that now we have to enter this text on the keyboard. And as far as we know, there is no such a collision algorithm, at least not public today. Okay, so let's see how we can crack these kind of passwords. The solution is very simple. If we have the previous files, we can go to the tracker, and here are the NTLM hashes, +, import hashes from SAM database, and we have already copied the SAM file, and it requires the boot key. That's nothing else but the system file. System file, it contains the boot key. Now for me it is this one. Oops. I just copy it and paste it here. Next. And I was able to get these kind of passwords, password hashes. And I have here the passwords, NTHash, LMHash. Here they are. And you can try to crack them. Right-click and use a dictionary attack for the LMHash. If you have a good password file, then most probably you are able to break it. You can add it here, add to list. The Kane has a default password file, but it's quite bad one. And from the word list, you are able to add. Here you are able to set some kind of hybrid technology, like not use only the password, but the reverse of it, 2 times lowercase, uppercase, number permutation, like instead of A4, instead of S5, instead of whatever, the O0 and things like that. You can use case permutations if you want. So there are some possibilities. You click on the start if you wait enough, and hopefully it will crack. With these default settings, it will not crack it, and I won't wait with the more sophisticated settings because it requires too much time to crack it. But it's made important to remember how fast is the cracking. If you take a look to this machine now, it is able to try about 2 million passwords per second in case of NTLM. I will show it with brute force. I will choose the character set, small letter, capital letter, numbers, and I know that the password one is 9 characters long. And here you can see the speed of it. Now it is even a bit faster, not a bit, but significantly faster. Now it's about 8 million per password per second, but it takes about 56 years on this machine to crack it. So this 9 character password is quite acceptable now. Okay. And so it was one possibility to crack the password. The other possibility, is the so-called patch the hash attack. It works on the following way. If you think about the network authentication protocols, every network authentication protocols today uses some kind of challenge response method. So network authentication is always some kind of challenge response. What does it mean? It means it works on the following way. If you take a look at it from far away, the client send a connection request to the server. The server responds with a random number challenge. Oops. This is the so-called challenge. And I want to emphasize that it is random. If it is not random, then there are other attack techniques exist. So it is very crucial, it must be a random number. But let's suppose that it is really a random number, so it works correctly. And the client encrypt this random number And during this encryption, it will use somehow the password hash. During this encryption, uses the password hash. The how does it encrypt, that depends on the algorithm, so what kind of network authentication we are using. For the client, send the result of the encryption to the server. This is the response. Oops. 5, server also calculates the response. And if the two responses is the same, then it will let you in. If it is not the same, then it will not let you in. It's so simple. So this is the challenge response authentication. And if you take a look at this authentication method, it uses the password hash, not the password. So that's why if you have the password hash, you are able to impersonate somebody on the network. So you don't have to crack it practically. It's enough to use it during the algorithm. Okay, let's see how we can do it. First of all, we will need another machine. I will use a Kali one. Good. Because I want to use the Metasploit. The Metasploit contains a module for push the hash, and that's what I want to use. And I have the password hash. It is already in Kane. Here is my NTLM and LMHash. Those are here. I log on to the Kali machine with the user root and the password Tor. That's the default username and password. I give it an IP address. 192.168.168. Let it be 55. Try to connect to my computer. This is my other machine. Good. They are able to see each other. And let's see how we can use the pass the hash technique. As I mentioned, I want to use the Metasploit, so I start the MSF console. Great. It is started. And I search for the PSXEC. Great. And I have here this exploit Windows SMB PSXEC. This is a tool that is able to run arbitrary executable on the remote machine if some kind of share is on the computer. So practically I will need to enable I have to create one share at least to open the port 445, the SMB protocol. And this command accepts not only password, but password hash as well. So if I use the show options command, here I can enter the remote host, the remote port, the domain name, the password, And here you can enter password hash as well, and the username. Okay. The username is never a question because the username is not a secret. The username is usually sent during the connection request in clear text form. So it's not a question how you can, usually it is not a big deal how you can get the username. That's not a secret. So I set R host, the remote host, 192.168.168.252. This is my target machine. I use the SMB domain. The dot is fine. The SMB user, that's simpler. Set SMB user, administrator, okay, and set SMB pass. And here I have to enter the LMHash and the NTLM. So those two long numbers. I will try to copy it, maybe it is working. If not, then I have to type it. Then most probably it will not work because it's practically sure that I won't be able to type so long numbers. But here I can try to find the NT hashes. LMNT, that's here, LMNT LST. The key stores everything in text files. It's here. I open it with Notepad. And I have the LMHash, column, and the NTLM. Okay, I have it. And I try to copy it to here. Okay, maybe it will work. Okay, so the password is set. And I also have to set the payload. So what do I want to do through this attack? I won't say that it is exploit because this is a built-in Windows feature. So it is not a real exploit, but we are just using a feature. We have the username and not the password, but the password hash, and we are able to run something. It's fine for Windows point of view. I want to set the payload for Windows Metasploit reverse TCP connection. Okay, it is set. Show options. Oops. Here it is. Oops. I have already set the domain name, the remote host. Just increase the size a bit. So I set the remote host. The remote port is 445. The password, the username, and the domain name dot. That's most probably fine. And this is a reverse connection, so my target will connect back to me. So if there is some kind of firewall, hopefully it is more possible to go out on a firewall than go in through a firewall. So that's why we usually use reverse connection when all target connects back to us. So we will use our IP address, lhost. Oh, what is my IP address if config? My IP address is, yes, it lost the IP address. It happens sometimes in Kali, I don't know why, but sometimes it lost the IP address. If I could remember, it was the IP address what I have used. 192.168.168.55. I want it to connect back here, and I don't like the port. For by default, it wants to use the port 4444. So your target want to connect to this port, but as you can expect, most probably it is closed on the firewall. So I will use the port 445. Okay. Oh, sorry, 443. That's better. So I use some kind of common ports that most probably open on the firewall every time, like 80, 443. Those are good candidates. The 445 is not an internal network. It could be good, but on the internet it's not. So I prefer this one. I check if everything is set up correctly. Hopefully yes. Target is set, remote port set, password username set, where to connect Backslash set. Okay. I test if the two machines see each other. Again. Typically always drop the network. Now it works. And exploit. Oh, one more thing. Show targets. In UWeb Kali, there are a lot of different targets. And the default one is the automatic, that not used to be work. The native upload or the MOF upload, those are used to be working. For example, 2. So the target is changed. And I got some kind of authentication error. Most probably I got it because I will check if anything on that computer is open or not. // 192, 168, 168, 252 /C $. Okay. At least it is open. Now it is unreachable. Again, Kali drop my IP address. I check again the password hashes. Go back to Kali. And I try to read it from the system directly. It's much better. Great. I will try those ones. Those ones. Copy. Oh, not here, sorry. Here. Set SMB pass. For this value. Great. I set again the IP address because most probably it is already forgot it. And try it again. Now it is working. So I got a nice Metasploit session. Session 1 opened. And I am in the Metasploit shell. For example, I open here a command shell. Host name. I will in the remote machine. IP config. It's really the target machine. So I was able to attack it by the help of the username and password hashes. So if you have the password hash, then you don't have to crack it. That's only a possibility. You are also able to use the push the hash technique to attack another machine. To tell honestly, since Windows 2016, there are some built-in defense against this kind of attack, but it is not turned on by default. If you go to the local security policy. Where is it? Local security policy, here it is. If you go to the local policies, security options, and there is the network security restrict NTLM family. As you can see, there are many policy settings. Practically, you are able to disable the NTLM authentication. This technique uses NTLM authentication, NTLM v2 now, and you are able to disable them. But honestly, the NTLM authentication is quite widely used in every network, so the system administrators not tend to turn it off because they are afraid of creating some disturbance on the network, on some outage or something like that. So usually this is not used, but theoretically it can be turned off, and then this technique is not working, but it is not turned on by default also. Also, you can audit here. There is an audit possibility, audit incoming NTLM and audit outgoing NTLM. So, for example, you can use some CM or some log analysis to monitor your network and try to catch if this kind of attack happens on your network. So not disable the NTLM, just try to catch it if it happens. This is another possibility, or just completely disable it. So this is what I wanted to talk about in this part. I don't know if you have any question.